And we are coming in. Hello, world. Let's get some stuff on the screen here. Good morning, the world. All right. And we're live and we're on time, sort of. Okay. And good morning. Sort of. Welcome. We are live from Santa Barbara in Winter Hall. The basement is freezing to keep us awake. We love that. We are in the final week of Westmont Mayterm, CS-030, studying Java and how to implement various kinds of algorithms that we might like to look at in the context of the Java language. This seminar is part of a 5-week class, and today's lecture is scheduled for 2 hours. If you are online, you can connect with us if you have access to our Slack channel via hashtag broadcast questions, and I'll be monitoring that if I can get my software up and working. I will be monitoring that anyway. And okay, I've got Keynote up, and it's Monday, and so I'm feeling that a little bit. Good to be back with y'all. Let's arrive, make sure our notifications are off. I got my phone is in silent, and I need to see if I can get the Slack channel up here. Let's see what I can do as far as that goes. Yeah. Okay, I don't know. Maybe can one of you guys monitor Slack for me till we take a break and I can see if okay. So otherwise, during our May term, we've been talking about regulation, but we've also been starting each week with this prayer, and I would like to do that again today, rather than maybe talk about regulation. So if you just join me for a second, arriving and being here, and acknowledging that this is a class that's taking place in a larger scheme of things, concerns that we have, a larger program and a larger journey that we're all on together, just because we're alive. So if you join me, please. Take myself off camera. I feel weird being on camera. Right. Oh Lord, grant us to greet the coming week in peace. Help us in all things to rely upon your holy will. In every hour of the day, reveal your will to us. Bless our dealings with all who surround us. Teach us to treat all that comes to us throughout the day with peace of soul and with firm conviction that your will governs all. In all our deeds and words, guide our thoughts and feelings, and in unforeseen events, let us not forget that all are redeemed by you. Teach us to act firmly and wisely without embittering and embarrassing others. Give us strength to bear the fatigue of the coming week with all that it shall bring. Direct our will. Teach us to pray, and you yourself pray in us, to the glory of the Father, and of the Son, and of the Holy Spirit, now and ever, and unto ages of ages. All right, thank you. All right, so administration for this week. We have a quiz on Chapter 13, which is recursion, that's due today. We have a drone programming assignment that's due on Wednesday, and we hope to tackle most of the kind of non-creative, just sort of setup and explanation work today. A quiz on Chapter 17 is due on Thursday, which is about tree data structures, and then we have our final on Friday, and that's gonna wrap it up for us. Questions administratively? That we'll handle the final the same way. We'll do an in-person final, and then we'll do a remote final, and it will be similar. It's cumulative, so it'll cover the entire class. We'll do the additional things that we didn't cover from the first exam will be on the final exam. It'll be about the same length, so expect about 100 questions. Same amount of time. Okay, so last time we did this in-class assignment where we created a Sudoku solver. We brought a bunch of different things together that we have been learning in this class. One thing that we brought together was the JavaFX UI toolkit, a relatively new addition to the Java standard libraries. You have to start your project a little bit differently through a different wizard as a JavaFX project. Unless you want to go through the pain of putting all the libraries in yourself. What that does for us is that gave us a structure that we could put a user interface on our program, like you see in the right there with the numbers. And then once we had the user interface in place, and that actually took a little bit more work than I expected because we spent a lot of time trying to get the error checking correct. So that if you typed in something into one of these squares that wasn't a number between 1 and 9 inclusively, or if you put in words, then we gave a little red error. Wouldn't solve the problem until that was fixed. So we had to do a little bit of work and make sure that the background color was right and that it got cleared, et cetera, et cetera. But the main reason why that we did this problem was to study the methodology of backtrack recursion, backtrack problem solving, because Sudoku is a pretty good case for this. In the textbook, you'll see a case study of solving something called the n-queens problem. And the n-queens problem also has, it's a chess-based problem, and it has a similar kind of board structure to Sudoku. Rather than putting numbers on a board, you're putting queens on the board, and you're trying to find places where queens won't attack other queens. So that has a very similar structure. And we talked about the things that have to be present for a backtracking puzzle to be able to be solved is that you need some way to examine a partial solution. And in Sudoku, what a partial solution is it's a board that has some numbers filled in, not all of them, but some of them. So that's a partial solution because you have to eventually get all the numbers filled in. And given a partial solution, you have to decide whether or not it is good as a final solution, and then you would return it. Whether you should abandon it because you've violated some rules, or you know that you're not going to be able to complete the solution given where you are partially, or that you should continue to work on it because as far as you can see in the partial solution that it is a viable candidate. So those are sort of evaluations you have to be able to do of your partial solution. That's necessary. And then you also need to be able to take the recursive step, which is to evaluate, do that evaluation of what we just said there in that first set of bullets. You have to be able to evaluate all those conditions, but you also have to be able to extend your problem one step somehow so that you can then evaluate the extended partial solution. In the case of Sudoku, the way that we extended the solution is we picked an empty spot and we proposed adding one of the digits to it. We added a 1 and then a 2 and then a 3, and we did that in a loop, and each time we added one number to our partial solution, we would recurse on it, and we would see if filling in that number was enough to solve the problem. And if we got back a null answer, basically that all solutions that followed on from our proposed extension were bad, then we would try 2 in the next spot, and so on and so forth. And eventually we were able to find a solution by doing it that way. And this idea, this abstract idea, can be used in all kinds of different problems where you can do this. So we thought about it generally as a maze, and if you had a maze, you could evaluate a partial solution by saying, hey, I'm standing somewhere in a maze, I've kept track of where I am, I know if I've gotten to the end, so that would be accepting the final solution. I know if I'm at a dead end, so I should abandon that solution, and I know that I can continue on this path if I'm faced with some sort of choice about going left and right. And then the partial solution, the extension of the partial solution in a maze would be, let's try going left, let's try going right, and you would basically recurse on, it's like you'd clone yourself, right? It's like you'd make 2 parallel universes. In one universe you try going left, in another universe you try going right. We kind of did that in Sudoku too. We kind of created a bunch of parallel universes where, hey, let's imagine that there's a 1 in the upper left corner, and a 2 in the upper left corner, and a 3 in the upper left corner. Well, we didn't actually have to go past the 2 because it turns out that when we put a 2 in the upper left-hand corner, that was enough to solve our puzzle. Because we were going through it in a loop, we were trying 1, 2, 3, 4, and we were trying from the upper left-hand corner down to the bottom right. What you can read from looking at this solution is that a 1 didn't work. If the 1 had worked, when we had put the 1 in the upper left-hand solution as part of our loop, we would have gotten that result back immediately. So something about that 1 made it impossible to solve the problem. And so 2, we tried a 2, and we were able to solve the solution, having extended our puzzle with a 2. At the very end of class, we had a couple minutes left over, and we tried to do a version of this software where we visualized the decisions that the computer was making, sort of seeing numbers sort of flip or get proposed and then backtrack along the way. And that turned out to be a little bit trickier than we expected because of the way Java FX does its updates. It kind of, every time you have to handle a button, for example, it expects you to not partially solve it. It expects you to do all your changes, and then it will redraw. And we needed to do these partial changes along the way. So all that is to say is that I spent some time trying to make a version of this where you could see the program making a bunch of proposed answers. and it would have required a pretty significant architectural change to how we were doing it. And so I just said, that architectural change would make the solution a little too confusing to understand. So I put the code for the version that just does it one shot up on Canvas, and so you can take a look at what we had at the beginning of class, and you can take a look at what we had at the end of the class so that you can study that as an example of backtracking. Any follow-on thoughts about Sudoku from last time? 3D Sudoku? No, that sounds nightmarish. You like have to rotate a cube around and.
No, it's like, so instead of having like one platform, like one dimension, you can have like 3 dimensions, and then they can like pop out or like push in or whatever.
So it's like you would have to look at not one Sudoku board but 9 Sudoku boards if you're.
It's only 3.
It's only 3 deep.
It's only 3.
And so what can't you do in 3 dimensions? You can't have in the 3rd dimension. There's 3 layers, and you can't have the same number in any of the 3.
So it's it's kind of weird, but it's like almost like you have like an.
So like you have to solve the problem 3 times in ways that don't overlap at all.
Kind of, it's a little different. It's images. It's like this.
Oh, yikes!
So it's like
I'm looking at Boaz is showing me a picture of 3D Sudoku, and if you've ever seen the game Hubert, which is an old arcade game, it looks like Sudoku and Hubert.
so you like follow the colored lines.
Oh, that's just not okay. That's like too. That's
And then there's boxes.
that's nuts. That's like a problem that should only be solved with a computer. You should never try and do that. It's all right.
I used to have a book with a bunch of them in it.
For me, when I kind of see backtracking, I suddenly start to want to solve everything with backtracking. Think, maybe I can like write a chess player that does backtracking. You kind of can. You can propose a move, and then you can act as the other player and have the other player propose a move. But one of the things that happens in backtracking is that there may be so many potential boards that you have to evaluate that the search space gets too large. So even though backtracking is powerful, in some instances you can't use it to solve the problem, because backtracking is at the end of the day a brute force solver. It's trying every possible combination until it finds one, and then when it finds one, it stops. And so for situations where every possible combination is like more than the number of atoms in the universe kind of thing, you can't really use backtracking to solve it. And chess is one of those problems. Backtracking would be like, well, I'm going to try moving pawn 1 forward. That didn't work. I'll try moving pawn 2 forward. That didn't work. But moving a piece one spot, opens it up to what are the follow-on things? Well, like maybe there's 20 different follow-on moves that the opponent can move. And then after the opponent makes 20, then you could make 20, and then they could make 20. And so already you're at like 20 to the 4th power, and you've only gone 4 moves into the game. So Sudoku isn't quite that bad. And Sudoku also has this benefit that you can stop searching really soon, because as soon as you see a violation, you don't go any deeper. You don't have to like completely fill out the board before you know that you've found a bad solution. So what's that creepy noise? Okay, I'm glad the building's not shaking. Okay, so today we're leaving recursion behind, and we're going to introduce a drone controller assignment. So today's going to be a little bit different, and that's going to be kind of workshop-y, and we're going to have to see how this works with our remote participants. But what we'll do is we'll walk through some of the procedures that we need to take care of, and then see how it goes. And really what we're doing is we're setting up for doing the homework assignment. So why are we doing this assignment? So at the very highest level, what we're trying to do is give you an opportunity to take all these pieces that we've been learning. We've been learning about classes, and we've been learning about data structures like sets and lists and maps. And we've been learning about control structures like while loops and if statements and if-else statements. But we've always sort of been looking at them, kind of in isolation as here's this technology. But we haven't really had a lot of opportunity, I mean, with the exception of like Sudoku, I suppose. We haven't had a lot of opportunity to like put it together and find a solution. You certainly haven't had the opportunity to just do it on your own. So that's what the drone controller is designed to do, kind of a little bit of a capstone kind of project. So give you the opportunity to use these tools to solve a problem. hopefully it'll be fun at the same time. So let's start by reading the premise of the assignment. And what I'm going to be doing is I'm going to be bringing up onto the screen the assignment, which is also in Canvas. So this is the PDF. Again, what's with the like ominous, distant, it's like a movie. It's like a bad movie. No, I think it's someone like rolling something heavy upstairs.
And it's playing through the speakers.
No, I think it's coming through the back.
No, it's coming through the speakers.
It is? Is it coming through the speakers? Okay, well. All right, we'll see what happens a little bit. Well, weird. What are we doing? Okay, we're looking at the drone controller assignment, and we're going to read the premise. And so what we're looking at is the assignment as posted on Canvas. So let's see if we can find that out. And as long, it's not like I don't have a bazillion things open on my computer, so it's possible that I could be playing something I wasn't expecting. But I didn't think I was. All right, so what we want is we want the assignment. Great. And wow. All right, we've really got to address that. Okay, so let's see. If I mute, I swear, it sounds like an earthquake or something, doesn't it? All right, hang on. For the remote participants, I am going to briefly switch off the screen. Wow, okay, and while the screen is off, I'm going to cycle through my windows and see if anything's playing. But it's like going to be a nightmare because I've got so much open. Maybe what? No, just me. Checking all my tabs. Nothing seems. Yeah, you can hear it remotely only because my speaker is picking it up, not because it's going directly over. Let's see. Well, let's see. One thing I could do is make sure that turn off the LC. Wait, what are you gonna do? Wait.
I was gonna mute it.
Yeah, try muting.
Oh, that one. Do you want me to text Greg?
Let me finish making sure that my computer is not playing anything. But we just muted it and it kept making noise, right?
Yeah.
So that's not going to be me. Let me just quit everything. This is. The system was off. Gosh, how are we going to pull this off? Okay, let's see. All right, let's see. We got to do something about the sound. The sound is distracting in the classroom. We're hitting mute on the classroom information or the classroom smart classroom. Mute is not causing the sound to go away. So what we're going to try and do is we're going to try and shut down the smart classroom all the way, That shouldn't be a problem for broadcasting. We're still broadcasting, but our screen is going to go blank for a second. So let's try that. So remote participant, sorry for this, but figure it out. Okay, so first system off. Next would be turn the whole thing down. When you start going down this path, all right, let's just give it a shot. Oh, that's not good. It's you still hear it? I still hear it. Is this still command speakers? We don't need the speakers. The speakers are coming direct. So it could be me. It's not me. It's completely disconnected now. That audio is going to the projector. Well, it's not plugged in.
Yeah.
All right, yeah. Who are you going to contact?
Greg.
Who's
HCC.
Who is Greg?
He's the academic technology team.
Like Doug?
Yeah, Doug.
Doug.
I don't know why I said Greg. That's what I meant.
Yeah, I can't. Okay, so what does that mean? All right, so can someone pull up YouTube and tell me what you see when I switch to? I'm not sure. Still hear me? Good. Right, that's intentional. Okay, so if what I'm gonna do is I'm gonna send out some video. See, because usually what the video is the video is the overhead screen. So boom. Okay, so I need to. Yeah. All right, so I'm gonna change my setup for a second and say that where we're going to be sending our audio from is going to be a different spot in the overhead screen. It will be this screen. Boom. And then oh, why did we turn this off? Did I turn this off? Oh, no, the whole system went off.
Yeah, you turn the whole system off.
All right, and now we've got the matrix, and that should be the case that you can see whatever's on my screen. Okay, so what I'm going to do is, because I've got stuff on my screen, I don't necessarily want broadcast to the world. I'm going to try and set that up, and then good. All right, so let's try and carry on as best we can until we get some assistance. So the setup for the drone assignment. Here we go. The year is 2027 and none of the speakers work. There has been a dramatic shift in the transportation industry from gas-powered vehicles to electric vehicles. Even as recently as 10 years ago, you would have only seen an occasional electric vehicle on the road. But today, the roads are filled with them. In Santa Barbara County, 90% are self-driving, and those are mostly operated by Uber. Unfortunately, Uber's surge pricing has gotten a little bit absurd, and it costs hundreds of dollars to get from Westmont to Vaughn's. Many scrappy startups have attempted to compete, but whenever a competitor's vehicle is on the road at the same time as Uber, Uber assigns a robocar to get in front of the competitor's car and drive very, very slowly. Regulators have identified this as grandpa mode, and it has caused competitors to lose all their riders and go broke. But now, Westmont physics majors have teamed up with the chemistry department to create flying vehicles. They have extended battery life and can bypass the pesky Ubers and their malicious behavior. Unfortunately, they do not have software to control them, and they are looking to you to solve the problem. In this assignment, you will create a Java class that controls a drone in a simulated Santa Barbara and compete to provide the best service. Really, the impending alien invasion is a little out of control. Okay. So the point is that what we're going to do is we're going to write some software, and what that software is going to do is it's going to control where the drones go. Okay. So that's the premise. We're going to get through this. That's the premise. And now let's summarize what it is that we're supposed to do for the actual assignment. So for the assignment, what you're going to do is you are going to write code in mydronecontroller.java. So one class in the code that we're going to download. And what the simulator is going to do is it's going to call functions in your controller when different events occur. So you're writing a class, and your class is going to have methods, and those methods are going to be called by the simulator. So what you do when your method is called is that you're going to do any calculations you might want, change any instance variables that you need to, anything that you care about, and then you're going to return from the method, and the simulator is going to continue. All right? So you are able to override many of the methods that are present in the parent class of the controller that you're writing, but you don't have to. You can overwrite the ones that you want to in order to get information about different events that happen. So we'll look at my drone controller to understand the pattern. Now it's all stopped. Doug's going to get down here. It's not going to work. He's going to give me that look again.
Yep.
Yep. When you override a method, the normal way that you're going to communicate to the simulator, right? So the simulator's called you, and you have to communicate back to the simulator something about what you want to do. Yeah.
We can play back the stream now.
Oh, that's good. Yeah, go on YouTube. Check it out. You can call several methods in order to tell the simulator to send your drone to a particular place, which is the primary thing that you're deciding to do. You're trying to decide where you want to send your drone, because your drone's going to pick up passengers, flying drone. So what you can do is you can call two methods. Both of them do the same thing. You can call the route drone method. So we're inside your method. You'll call route drone. You'll send it the drone that you want to send somewhere and the place you want to send it. You can either use this class that's provided by the simulator called place, or you can name the place that you want to go by a string. So that's one thing. That's telling the simulator where you want your drone to go. The other thing that you have to do is you have to publish what's called a manifest, and the manifest is informing the passengers where your drone is going, because we want to have the ability to tell the passenger something different than where the drone might actually be going next, because you might want you might envision going to someplace far away, like a bus, but making stops along the way. So if you're at position A and you're going to go to B and go to C, you want to tell the passengers that you're going to B and C, and so you want anyone that's going to get on your drone to go to B and C, but you can only tell the simulator to go to the next spot. So the drone manifest says, okay, the drone that I pass as the parameter should announce that it's going to the following place or places. If you just want to announce that you're going to one place, you just pass it a string. But if you want to announce that you're going to multiple places, you pass it a set of strings. And then having done that, as soon as the drone lands, passengers that want to go to any place that you've identified the drone is going are going to board the drone. So after calling those methods, the method should return, and right, so where a drone's going and where the drone tells the passenger is going can be different. The passengers are going to board your drone if they're going where your manifest says you're going. The drone actually starts going to the place where you route it. And if for some reason your method takes longer than 10 real-world seconds to return control to the simulator, like you have an infinite loop, for example, actually taking 10 seconds to do some evaluation is probably a lot longer than any healthy code is going to do. But you might have an infinite loop. And if that happens, the simulator is going to say you've taken too much time, and it's going to quarantine you as a result. All right, so let's see. What I would like to do then is to show you what we're actually going to be evaluated on. And let's see if we can go here. We'll go here. That. All right, so I just want you to submit the drone controller file, the one class. You can do it in groups if you want. You can do it in groups of up to 2 people if you want to work together to come up with it. And if you do that, I only want one class submitted. The way this assignment is going to run is we're going to have a world where there's just one company running in the world at a time, and so you guys are acting as a company. And you're only going to control one drone at a time, and each drone can only hold one person, and the drone doesn't run out of gas. So it can go as far as it needs to go, and it won't run out of power. There are going to be 10 locations in the world and 10 possible passengers to pick up. And what you're trying to do is you're trying to get to you're trying to hit different thresholds in terms of what you're doing with your drone. So those thresholds are, let's see, go away for a second. So the first assignment is turn in a mic. So I'm going from the bottom of the assignment PDF. I'm saying here are the different thresholds that you have to get to. If you turn in a My Controller class that compiles okay, that's worth a D. If you turn in a My Controller class that delivers one ninja to one destination within a reasonable amount of time, as specified there, that's a C. If you deliver two ninjas in a reasonable amount of time, that's C+, 3B minus, 4B, 5B plus, 6A minus. If you deliver 10 ninjas before the threshold, that's worth an A. And usually we have more than 4 other groups in the class. I don't think we're going to have that many. So usually I give an A+ to anyone who beats 10 other people in class in terms of speed. Since we have a limited number of people, we'll just change that and have it be the top person in terms of speed of delivery. Right? So a little bit of competitive pressure, but the competitive pressure is just to go from A to A+. So that's all. That's at risk there. Okay, so let's stop there for a second and just, this is sort of high level, having not seen this at all, it's probably very confusing. Can I help to kind of answer any questions or anything at this point before we try and install the code and get a little better look? Or what I can do is I can play a video of the system working. Okay, so what I'll do is I'll show you the video of the final competition from last semester of 2 teams working together. And the thing that's different about this simulation is that each team was controlling 10 different drones, 5 or 10, I don't remember. And there were 1,000 ninjas in the world to deliver, or the passengers are ninjas, I didn't say that. And there were 100 different locations, and the drones could run out of power. So there was like, when you run out of power, they blow up. All right, so let's see if we can take a look at that. Okay, here we go. It turned out that it was 2 students whose names I probably shouldn't be putting. Okay. So here you see drones bouncing around, a little bit glitchy because of the compression, but you can see that they're flying. They're going up and going down on the map, and you see bars on the bottom that are indicating the success rate. So green means that passengers have been delivered. Red means that passengers are on board. And black means that passengers have died because you blew up, because you ran out of energy. Again, we're not going to get to that level in this class because we just don't have enough time. But it's a little too grainy actually to be able to see it very clearly. So that's where we're going. And so let me just put this in context now. So each one of those drones that you see zipping around like gnats are paired with one object that you're making. So there is a Java object that is associated with one of those drones, and whenever that drone lands, or at any moment when there are different events that that drone experiences. So for example, when the drone lands, you can have the simulator call a method when it lands. You can have the drone call a simulator when it's recharging. You can have it call it when a passenger gets on board, when a passenger gets off. There's about 20 different kinds of callbacks that you can ask for. Most people just did one. They just asked to be told when the drone is doing nothing. And when the drone is doing nothing, the code responded telling the drone what to do. Yeah. All right. So so now, having seen that, any more questions or any sort of clarifications? I mean, yeah. Okay. So what we should do now is we should try and follow the instructions for installing the software. So installing the software involves using some software called Git. Git. In fact, Git is some pretty sophisticated software. It's used for sharing projects among groups of people that are developing, where an individual is developing as part of a team, and Git is used for keeping track of all the files that are associated with the source code. Because usually a project has lots and lots of files, and if you have lots of people working on lots of files, it's really hard to keep all the changes in sync as one person changes one, and another person changes another. So what Git does is Git manages a whole collection of files, and as people make changes to it, it helps to merge it and keep it all sane a little bit. There's a company called GitHub, and GitHub runs a Git service in the cloud. Those are two different ideas. One is the software, and one is a company that uses that software to run a cloud-based collaboration point. But it might be relevant because our software is on GitHub, and actually there's just big news today that Microsoft bought GitHub. It's kind of a big deal. All right, so what we need to do is we need to open Eclipse, and we need to create a new project. And so we do this in a slightly different way, but what we're going to be doing is we're going to be downloading code from the internet. Now, I can't do this on my computer because I already have the code on my computer. And so what we kind of need to do is walk through it together. So yeah, Boaz.
Slide comment from James.
Yeah.
Pretty sure my computer is going to freeze with this, with the simulation. Does changing the constants make it easier to run on lower-end laptops?
Yes, yeah. I think you'll be okay, James. So the comment from James is James thinks the computer's gonna jam up, and there's various things that we can do in order to lower the demand on the computer. We can make the size of the screen lower, and there's also a setting in the code where we can lower the resolution of the models too. So I wrote this code, so it's not like some mystery code. We know what it's doing. Okay, so let's start by going into Eclipse and opening a new project. But the way we're going to do it is we're going to do import a new project. And you know what? Since we have the noise, whether the screen is on or not, let me turn the screen back on, and then we can follow along. So, okay, so let's see. That means that, yeah, let me do that. Okay, so people at home can already see what's on the screen here. So let's, here. And let's see, I'm going to have to go back and switch out my... We'll wait for that to come up. Oh, please no. All right, and now why isn't the... Oh, because we don't have plugged in the video. That's right. Okay. Sometimes there are reasonable reasons. Okay. All right. So we have our screen up. Great, and we are scaled at the size we expect. Great, and we are going back to our normal display of overhead screen, and we're firing that up. Great. And now we're going to go back to showing. Let's go to all right, great. So here's what we're going to do. All right, so now we've got that on the screen so people here in the classroom can work. So what I'd like to do is maybe just, I guess all of you need to load it up. So let's walk through this together. Let's go in Eclipse. We're going to import the code, and we're going to want to go under File, Import, Git, Projects from Git, and then Next. And how... I guess I can show you that much here on the screen. So up here, File, Import. You're going to want Git, Projects from Git, Next. You're going to want to choose Clone URI. So that means clone a universal resource indicator. So that means a it's basically a web URL. We're going to clone it, means we're going to take a copy from the internet and put it on our computer. So we'll hit Next there. And then under the URI, you're going to want to do this HTTPS github.com/github.com/djp3/droneworld. That Git. The host is going to get filled in automatically for you. The repository path is going to get filled in automatically for you, and then you can hit Next. So far, so good? Read on the right. Let's see. Maybe I did something wrong with my settings. Let's see. Too many T's. One T in HTTP. All right. Now, when Git keeps track of software, it keeps track of changes in software along particular trajectories, like possible different universes of changes. And so what you see here is you see all the possible different sets of versions of the file that are being edited at one time. And so what you want is you just want Drone World 1 for students. And you can uncheck everything else. You'll hit Next, and then it'll ask you where on your computer you want to store this software. And this is the point at where mine starts to break because I already have it on my computer. So you can store this anywhere you'd like. A reasonable place to be would be in your directory for this course. So it's just a directory where the source code is going to be. You just need to remember where it is. And then you should, then you'll hit Next when it's filled in okay, and then the code is going to download, and you're going to have import existing projects is going to come up as a wizard. You'll click Next, and then you'll select Drone World, and you'll select Finish. Yeah, Lisa. Yeah, what did you type in on yours? Yeah, you should create a new subdirectory in there in order to do it. So if you hit the browse button, it'll let you do it. Because it writes so many files, it wants a fresh directory and put everything. All right, now so ignore all this for a second. What I'm going to do is I'm going to grab the code I already have. This is where you should be. Select Drone World and Next. And then we're going to import existing Eclipse project, Next. And then pick a name for it. I'm going to just make, I guess that's it. All right, and Doug has arrived. Hi, Doug. So before you come over, we're broadcasting on YouTube. So there's, well, they have, but as long as you're happy with what's going on. So what's happening is that our speakers were making a noise, and we actually turned this system entirely off, all the power, and it was still making that noise. So, and we're not even using the speakers, as far as I know. So it's not doing it right now, but you hang out for a second, come back. I'm not quite sure what to do, but it was a little bit distracting.
We love the intermittent problem.
Well, it wasn't intermittent for, but well, didn't I say this? I said this. Doug is going to come in. I'm going to say the speakers are making a noise, and he's going to give me the look that he gives me.
And I believe as a scientist, like you guys have to have evidence to. So I don't disbelieve it until I can see that the symptoms. I can't fix it. But, yeah, that's weird.
Well, if you don't mind hanging out for a second.
Yeah.
Okay. What's that? Maybe if you could, I know, maybe if you could just sit here forever, then we won't have any problem. It sounded, I mean, it sounded like interference. the wires somehow, but we haven't had it all semester, so I don't know why it happened today. At first, I thought it was someone rolling a heavy cart upstairs, but then everyone convinced me that no, it's coming through the speakers. Okay, so meanwhile, we're moving on. So after you've done all that, you should have a project in your Eclipse that's called Drone World or whatever you chose to call it. And the first thing that we need to do is, so I wrote a bunch of tests for it, so we're going to run the test. But the first thing you have to do is you have to right-click on the project and scroll down to Maven and just hit Update Project. And what that's going to do is this is a kind of project that's connected to other libraries on the internet. So when we hit Update Project, it's going to pull in all those libraries from the internet and make sure that they're present. And so you hit OK for just the one you're interested in. And then down at the bottom, you'll see some progress indicators of how it's doing. It's doing OK. All right. Because there are tests in this project, because I'm a software developer that believes in tests, you can right-click on this project and do Run as JUnit tests. And if it has installed OK, then everything should go green, just like you would with any tests. But I wrote tests for my code, so this helps me in my development to know it's doing what it wants, but it also helps us in our installation. It's going. So question 1, have you guys been able to run the tests? Everyone got that? Great. All right, that's relatively painless. All right, so then the next thing that you want to do is, rather than running it as a test, you want to run it as a Java application. And it's going to ask you which class you want to run as a Java application, and you want to find the simulator class. That should be very. And when you run it, you're going to get a splash screen from JMonkey Engine, and JMonkey Engine is the graphics library that's supporting this. And you can pick a screen resolution down here. And to James, who's watching online, if you select a lower screen resolution, you don't want to go too low, but if like 800 by 600, you can also reduce the color depth and the anti-aliasing, and that might help reduce the overhead as well. And if you hit continue, you're going to get something, and it depends a little bit how the system is set up. It's going to take a few minutes to load because it's currently loading the high resolution version, and if you look at the output on the console, you'll see stuff coming through. And then it'll run the drone controller. And you can see that in this case, we just have one drone running, and it's going around to pick up the ninjas, but I think it's got its controller is very dumb. And so it's not doing anything clever. You can zoom in and zoom out by doing 2 fingers, and if you click and drag, you can kind of change the view a little bit. The next question is, do you see this on your computer?
I'm going to go, but I'm here, so I'll come back.
Okay, thanks. Yeah, it seems to have stopped for the time being. Okay, thanks for coming down. All right. Instead of running it as a JUnit test, we ran it as a Java application and selected the simulator class as the class to run. All right, so now this is a little bit better graphics, and we can see a little bit better what's happening. You can see that there are 10 locations in the world, and those are the ones that have the little box and it has the text over it. This is a map of Santa Barbara, gratuitously screen captured from Google Maps. And those are locations actually in Santa Barbara. The ninjas are not in Santa Barbara. Also, Santa Barbara is not quite so flat, but that's okay. You can see that there are little ninjas. Those are the passengers that we're picking up. But what's happening right now is that our drone controller's going back and forth between In-N-Out and I think that's Trader Joe's. And the ninjas don't want to go there. And so we're saying where we're going there, and then the ninjas aren't getting on board, and our drone controller's just going back and forth. In an ideal world, we would be doing something like looking at where the ninjas are and deciding to go there instead. So this is our goal. So now, having gotten this far, how are our questions? McDonald's, yeah, that's right.
And it's picking up the people from McDonald's too. Makes a lot of sense.
Well, I don't think it is picking up the person from
Well,
McDonald's.
it's not actually picking them up, but it's going from McDonald's to In-N-Out.
Yeah, I don't think it's doing anything very smart. I think it's just going to the first place it can find. The first place. Okay, so good. So to quit that, you hit the button on the upper left, and that closes the project. Upper left, yeah. All right, so that takes us to, that's installing the code. Great. So let's start by understanding how to control the simulation. And so this may be something to James's point. What can we do in order to modify the way the simulation is running in order to test our code or to do other things? So let's take a look at that. If we open up the project here on the left and go into the source file, you can see all the different classes that are here. Your code is located in reference, and so the drone controller, my simulation controller, is the one that's running right now. And so if you open that up, you'll see this is the code. That, sorry, not my simulation controller. My drone controller is the code that's running right now. And so what you saw, that behavior of it bouncing back and forth between McDonald's and In-N-Out, is the behavior of this drone. So let's start by changing the drone company name. Let's start by changing it to your name, just changing the string there. And then you can change your drone name as well. Save that, and then rerun the simulation, and you can kind of see that what happens as a result. Wait a second to load up. Okay, so now you can see that the text underneath the drone has changed because the simulator is asking what label it should put on it. And if you look down at the bottom, the score has changed as well because that's my company name, what I changed it to. So the first thing that you can do to control the simulation, besides just, ultimately we're going to be controlling the simulation by controlling our drone. But the first thing that you can do is you can just change the labels that are on, that are being called by the simulator. And so what you can see here is that there is some function that you're overriding from the parent class that gets the next drone name, and that next drone name is, you answer the simulator, here's what you should call the drone. And so there's like no control flow here. There's not some program that you're running that calls get drone name. You're providing a class that the simulator is making these calls into. So the simulator asks what the next drone name is and asking what the company name is. So let's go to my simulation controller. This is something that is used by the simulator to try and help control the aspects of the simulation. So let's walk through these in turn. So the first thing you can see is same random numbers each time. So some of this code is generated, some of the environment is generated randomly. For example, which locations have ninjas, that's random. And because you're trying to debug things, it can be a little bit headache inducing if every time you start the simulation, the ninjas show up at different places. So by setting same random numbers each time to true, the ninjas get distributed randomly-ish, but every time you run it, it will be distributed the same way randomly, if that makes sense. Because if you put some sort of a debug breakpoint in your code so that you can see what's happening, you want it to be the same every time, even if you're not entirely sure where they're going to be. So for debugging, that's certainly helpful for true. When I actually run it, I set that equal to false to see how your drones do in a more random environment. The next one is high resolution equal to true. So this is maybe something that James would appreciate. If you set this equal to false, rather than drawing the fancy drone that looks like the claw from Toy Story, it's going to draw the drones as boxes. And the other thing that it's going to do is it's going to load the program a lot faster. If you set that equal to false and then hit run, after you get the JMonkey engine, you'll see that it takes a lot less time to launch. So now you can see the drone is just represented as a blue box. And that's just, it's not very good for demo, but it's good for just getting things up and running quickly if you just want to test some small changes and don't want to wait forever for the graphics to load. You notice that the box disappears if you're too close to it, so that's a property of the graphics engine called clipping. If you're too close to something, the camera won't draw it, and so if you do find yourself in that situation, you just zoom out. So as it flies towards me, it's going to clip. There, it's clipping. When I zoom out, it's just too close to the camera. All right, the next thing you can control is drone model count. So this doesn't have to do with how many drones are being run. This has to do with how many graphics are used. And so if you, there are 4 different models of drones that your drone can be drawn with. The more that you increase that number, the longer it takes to load. So if you can have up to 4 different kinds of drones, but it takes a long time to load. So set it 1 for now, and that's the claw drone. The simulator speed indicates how fast the simulation runs. This doesn't, there's sort of there's a virtual clock in the environment. So simulator speed doesn't change the virtual clock. Everything appears to the drone to be running at the same speed. But what this does is it just speeds up this rate at which the simulator is executing the same commands. And so if you run it with a simulator speed of 100, you're going to see that everything zips around a lot faster. Again, sometimes that's helpful. Here we go. Sometimes that's helpful for just debugging stuff, but it can be, I mean, sometimes it's helpful for running your code, but it can be a little bit crazy making if you're trying to understand what's happening for a moment. Quarantine drones is currently set equal to true. You probably want to change that to false, and here's why. If you put a breakpoint in your code and you wait until the simulator calls your drone class, and then your code breaks so that you can evaluate, so that you can look at the state of your instance variables and you can evaluate the flow through your code like you do whenever you debug. The problem is that you have paused your code running, and if you pause for longer than 10 seconds, the simulator doesn't know that the reason why you're paused is because you're debugging. The simulator thinks that your code is not running. And so it's going to quarantine your code, but you're not, it shouldn't be. It should just be, you're just pausing it so that you can evaluate it. So while you're debugging, quarantine drones should probably be set equal to false. Simulation end time is how many clock ticks the simulator runs for. 20 million is just a default. You don't have to change that. So those are the basic aspects of how you control the simulation. Is that any questions about those components? So let's see, just to clarify, for the purposes of running right now, what I recommend is the following that are up there, that you should have same number, random numbers each time true, high resolution to false, simulator speed probably 100, drone model count 1, quarantine drones false, and simulation end time 20 million. When it comes time to test it before you turn it in, you're going to want to change the top one to false. I'll put little, because you want to see if it works with actual random numbers. And you're going to want to set quarantine drones equal to true, because if you have bad code, you want to see that. So those are the 2 changes that you should make when you're like testing to see whether it's ready to submit. You probably, if your code's reasonable, you probably won't see any change. Okay, that is the basics of running and controlling the simulator. And so you can see that everything we have edited has been under the reference package. The simulation controller controls parameters of the simulation. The drone controller is where you're going to write your code. Any questions? Time being, poets. In your simulator.java? Okay. What do you got?
In the import, line 16 has an error for me.
You have an error on line 16 where it says reference.mydrone. Okay, that's a little weird.
The reference, or the import reference.mydrone controller cannot be resolved.
Okay, let's take a look at that for a second.
That one you can delete because those are for competition. Would that be because you don't have the reference.jar? Let me see. Live there. Right click on reference controllers.jar. Go to build path. Here, right click over there and go under source.
Okay, so our friend, the popping speakers are back. Um, so Boaz had a problem here in simulator, some lines that weren't getting compiled okay. That is, so to make sure, here's what you want to double check on that. You want to come down here to the lib folder. You want to see reference controllers.jar. You want to right click on that, go to build path, and make sure that it doesn't say add to build path. If it says add to build path, you want to add it to build path. But if it just says configure big build path, then you're fine. And then you can go back to simulator.java and go under source and organize imports, and it should clean that up. Yeah, so the robo drones are used when you're competing against my classes. And so I've got them here because I have the source code, but the source code that you have should be in reference controllers.jar. But if you go under source and organize imports, does it go away? Let's take a look. Oh, right click, make sure you click in this. Okay, so one problem we had was that it didn't look like organize imports was a choice, like right here. It's grayed out. To get that, you have to make sure you've brought to the foreground the simulator.java file, and then you can organize imports. Okay. How are we doing? Okay. All right. Any comments from James online about struggles? All right, so let's talk about how to access information about the world in the drone controller. To access information about the world, let me go back to our documentation that's part of the assignment. And what you can do, all right, so what we did, we already talked about adjusting the simulation with these different constants. When you are in the context of your drone controller code, there are a number of different callbacks that you can get access to. So let's see if they're listed down. So each one of these events is a state in the drone's life cycle. And you can, if you want to, you can get information about that state. But the more important thing about it is that these are the different things that it happens to a drone as it moves. So beginning is when the drone is just starting out in the simulation. Embarking is when the drones start being boarded. Ascending is when the drone is lifting off. In transit is when the drone is moving from one place to another. Exploding is if you've run out of fuel. We won't run into that. The passengers on board die. Dying means that the drone has hit the ground after exploding, and then dead means that the drone is no longer functional. That's the bad thing that happens in transit. Otherwise, you descend. So descending is something that happens. Passengers disembark. Then your drone recharges. And then if your drone doesn't have any more information about where to go, it idles. And so this is like idling for 1 minute only. It will idle as long as it doesn't have anything to do. And if it idles too long, it's going to get quarantined as well, because the simulator assumes that if you're idling, why am I wasting my CPUs on you? And then finally, quarantined is when you've had some bad behavior and you get quarantined by the simulator along the way. So let's go to the code and look at how that maps into what's happening with the code. Let's see. Sorry. Oh. So the place to look is in drone controller skeleton. Drone controller skeleton is in reference, and drone controller skeleton is the parent class of drone controller. So if you look at your drone controller, you can see that it is a descendant of drone controller skeleton. That means that the simulator is going to call your class for many different methods, and if you don't override them, drone controller skeleton is going to answer the request for information instead. So drone controller skeleton has everything that's possible for your code to answer to. So let's start at the one that we see being executed. If we go into drone controller skeleton and we go to drone idling the method, you can see that there's a method there that returns nothing, void, it takes as a parameter a drone, and if you don't override it, what drone controller skeleton is going to say is simulator told drone, it's going to pass the drone's ID, that the drone was idling. Now, if you look in the console, you can see all kinds of messages that are getting printed out about what the simulator told this drone was happening. They're in transit, they're charging, they're disembarking. So all those methods, all those messages that are in the console are coming from the drone controller skeleton for those methods that haven't been overridden by my drone controller. So you can see in drone controller skeleton all these different methods that are called by the simulator when different things happen to a drone. So when a drone is done recharging, this method gets called. When a drone starts recharging, this method gets called. When the drone is in the middle of charging, this method gets called. So depending on what you want to do, you can get access to a moment in time when any of these events are happening. In practice, though, if you go back to my drone controller skeleton, the only one in the example that's been overridden has been drone idling, the moment when the drone has nothing to do. And so in this method, code can be written. And the first thing that this sample code does, that's been distributed in the repository that you downloaded, is it calls the drone controller skeleton's drone idling method. If you don't do this, the drone controller skeleton's drone idling method won't get called, and you'll just take over the call entirely. Why would you want to call the drone controller skeleton's drone idling function? Well, we can just look and see what's there. Drone idling is going to print out simulator told drone idling. So the only thing that calling the superclass does is it just prints out the standard message so that you see some logging about what the behavior is of your drone. Okay, great. So we just output that we've been idling. And now what I want to work through is I want to show you how to access the different kinds of information that are available. So I'm going to go back to the PDF document. But first notice here that the simulator is calling and that it is passing the drone that is currently idling. Right? So you have access to this variable drone, which is a drone class. So now if we go back to our PDF document, the simulator has several methods that you can make use of. So I am now on page 4 of the Drone World documentation, PDF. 3 methods in particular are really helpful. You can get a set of all the places by calling simulator.getPlaces. So this is going to return a tree set where every element of the set is a place object. Now you don't know much about a place object, but you can imagine that it contains all the information about a particular place in the world. You can also ask for all the information about all the drones in the world. You get back a set of drones. And you can also ask information about all the people that are in the world, and you'll get back a set of people. And so as you evaluate what you want to do, you're probably going to call one or more of these methods in order to get a list of all the different choices that you have to decide between. Now, a particular place has some things that you can call as well. So if you have a place, if you have a reference to a place, you can ask for its name by calling .getName. It's a method, getName. And that'll return the string. In this case, it'll be like In-N-Out or McDonald's. If you call getWaiting2Embark, you're going to get a linked list filled with people. So just like we've talked about how we use lists, lists is an ordered set. And so the people that are at a particular place are in line waiting to board a drone. And so you can look at that line and say, okay, who's first, who's second, who's third, and so forth. And when your drone lands, the ninjas get on your drone in the order in which they're in the line if they want to go to where you're going. So what happens is you'll say, I'm going to a particular destination, I'm going to McDonald's, and then the simulator will walk through the people that are waiting on the line, and the first person that wants to go to McDonald's that's in line will get on board your drone. That linked list of person objects, well, if you want information about a person, you can ask get destination, and that'll give you a string, which is the place where they would like to go. And you can also ask get state, and that'll tell you whether the person is waiting or has already gotten where they want to go, etc., or dead. If you have a drone, you can ask for the drone's state, what the drone is currently doing. So for example, one place where we have a reference to a drone is the parameter to drone idling. So you could call drone.getState, and what you would get back is a drone state object, and that's probably going to be drone idling. should be drone idling if you're in the drone idling method. You can also get the charge on your drone to see how much fuel is left. You can get the capacity of your drone to see how many passengers your drone can carry. In our world, it's only going to carry one, and the charge doesn't matter. So there's really not much point in this assignment for calling get charge or get capacity. You can also call drone.getPassengers and get a set of all the people that are currently on your drone. And that might be helpful if you wanted to look to see who's on your drone to see where they want to go. Now this is going to be a set, but again, in our running of the program, we're only going to see that there's one person ever on our drone if there's anyone. Okay? So if the drone states correspond to the different life cycle positions of your drone. So let's go back now to the code and let's look at what the reference code is doing. So in our reference code, after line 29, when we call drone idling, and that's going to call our parent class and just output the message that I'm idling, we're then going to ask for the current place where the drone is going. So drone has this method called getDestination. Well, gosh, what other sort of methods are available on the drone? Well, you can go to the drone class if you want. The code is available to you. You can also just get the quick answer by typing drone and then a period, and you'll see all the different things that are available to you in terms of accessors or getters. So all the things that start with get are things that you could get information to. How long does it take to go ascend? What's its capacity? What's its charge? What's its company name? What's its controller? What's the destination time? What's destination? All this kind of information is available to you. But what we're interested in right now is getting where the drone was going. And so the way this works is that the drone lifts off and goes somewhere, and then it lands, and then it idles. So if you ask drone.getDestination in the context of the drone idling method, you're going to get where the drone currently is, because that was the last destination it went to, and now it's sitting there idling. So calling getDestination, we capture this place, and that is where is the drone. And so we're just having a variable that references the place. If you want to actually know the string, you could ask, where is the drone? So this is a place object. Well, what can you call in that object? Where is the drone? Well, let's see, get name. There you go. Get name is going to return the name of the place where you're at. So McDonald's or In-N-Out, whatever we've got. Then on line 33, at least in my code, we do something that we haven't done so far, which is we call this method called getSimulator. There's one simulator, and when you call getSimulator, you're going to get it back, and you have to call that in order to do the three methods that we mentioned here at the top. So these three methods, get places, get drones, and get people, are kind of global data structures. And so if you want to get that information, you need to call getSimulator first. That'll return a simulator object, and then you call getPlaces. And what that then returns is a set of all the places in the world. So what I did is I captured that, and then I removed from that set the place where the drone currently is, because I don't want the drone to go there, because I'm already there. So I don't want to consider that as a possible place where they can go. On line 36, I make a check. I make sure that there's something left, that there's somewhere left for the drone to go. And then on line 38 and 40, I send the command back to the simulator to inform the simulator what it is I would like my drone to do. So the first one is to set the drone manifest. So the first thing you can do is you can see I'm calling getSimulator to get a reference to the simulator object. And then I'm calling setDroneManifest so that the simulator will announce to all the passengers where this drone is going. The first parameter is, which drone are we talking about? Well, it's the same drone that you got passed in, because this is you. This is the drone that you're trying to control. So you set the manifest for that drone, and where are you going to have it tell the passengers that they're going? Well, in this code, all we do is we just pull off the very first place in this set. So we say places.first. We can only call first on a set because it's a tree set. If it was a hash set, there wouldn't be a first method, because a hash set doesn't have any notion of any ordering at all. A tree set just puts things in alphabetical order. So actually what this is going to do is it's going to send the drone well, let me clarify. On 40, we actually send the drone to this location, but you can see that we tell the passengers we're going to one place, and then we actually go to that place. So there's no disconnect between those two things. By calling places.first, what we end up doing is saying that we're going to send the drone to the place that is alphabetically first by name after we've removed the place where we currently are. And so In-N-Out and McDonald's, which is what we're going back and forth between, I think, those apparently are alphabetically the first locations in our list of all the names. It's kind of surprising that M is our alphabetically first place. I think TreeSet has a last method. So if instead of going to the first alphabetical, we change this to last, now we're going to end up going back and forth between the last place alphabetically after we remove the place where we currently are. So now if we run this code, even though the drone starts at the same place, it zips off to Winter Hall, because Winter Hall is alphabetically last, and then Trader Joe's, and then Winter Hall. So apparently, Trader Joe's and Winter Hall are alphabetically last in the list, and when we go to Trader Joe's, we go to Winter Hall. When we go to Winter Hall, we remove Winter Hall from our list, and then we go to the next last alphabetical place, which is Trader Joe's. So this code isn't very good, because all it's doing is going to places based on its alphabetic order. That's not a very good algorithm, because that algorithm does nothing with respect to who's waiting at a given location, nor does it pay attention to where that person wants to go. It's just going back and forth between two places based on places that are available. Okay, so that's how to access the information. The three basic data structures in this world are places, drones, and people. And so those three things are the information objects that you make your decisions based on. Understanding the states that a drone goes through, maybe we've talked about this enough as much as we can at this point in terms of being interested in what's happening. And so understanding how you control the drones, that is route drone and route drone manifest. And so now what I'd like to do is I'd like to take a second and just brainstorm some strategies for solving the problem. And let's see, why don't we do this? Let's see. What we'll do is we'll just pause. Man, I don't know if you can hear you, Boaz, when you're listening to that. Can you hear you guys talking? I mean, you can certainly hear the annoying Armageddon noise from the speakers. But, so. Okay, here's what I'm going to do. I'm going to turn up the gain on the audience mic and see if we can sort of try and hash out together what some strategies might be. Okay, so let's see. To do that, I'm going to turn off the audience audio. Turn off presenter audio. And audience audio. And we'll try test. You may test, Boaz.
A, B, C, 1, 2, 3.
Again? Oh, too loud.
B.
All right, that's as loud as I'm allowed to go. Okay. I can turn up the mic a little bit. All right, test. All right, I think that you can be heard loud and clear now. It might have background noise as well. All right, so let's see. Let's talk about what we might want to do instead. So what are some ideas for how we might control the drone controller that don't involve alphabetic?
The amount of people at one place.
Okay, amount of people at one place.
Ninjas.
Yeah. So in this running of the program, we're only going to have 0 or 1 at a given place.
So if it has a ninja.
Okay, so it doesn't make sense to go to a place that doesn't have a ninja. Does that make sense? So what would you do in order to figure out the places that have ninjas?
I don't remember all of our code.
Well, just conceptually, not like literally.
Ask the place if it has a ninja.
Yeah. Okay. So what you could do is you could call the simulator and get places, and then you could do a loop that goes through all the places, and you could get the people waiting to embark for each place and check to see whether it's greater than 0, or if it's 1 in this case. And then if it is, then that's a place that has people. So you could imagine creating a set that's empty and then going through all of the different places, and every time you encounter a place that has a person waiting, add that place to your set. And then after you're done searching all the places, then you have a reference to a set that has people in it. And then you can decide, well, which one do I want to route my drone to? That's a choice. Good. Now, what if you have a person on board? What if you actually have a ninja on board? What do you want to do?
Drop them off at their place.
Yeah, because you can't carry more than one. So just going around to all the different places that have ninjas, once one gets on board, that's not helpful anymore because you can't take anyone on board till you deliver them. Mm-hmm. Okay, so that sort of makes us think through what's the logic that you want to do first when you're idling?
If statement, if there's a ninja on board, drop them off.
Yeah.
If not, go to your stack or whatever.
Yeah, so first thing, check if you have a ninja on board, and if so, you want to go to their destination because you just want to get them off board, and your job is to deliver ninjas. Mm-hmm. All right, if you don't have a ninja on board, then you check to see, well, maybe the next thing to do would be to check to see if there's any ninjas where you are, because no point in going somewhere if they're already there.
Yeah.
If there's already ninjas there, then find out where that ninja wants to go and say, hey, that's where I want to go. Hey, turns out I want to go exactly where you want to go. What a perfect world. Harmony, peace. Wonderful. All right, so that'd be step 2. Step 3 would be if there's not a ninja waiting where you are, then you want to come up with some choice about how to pick a place, and then you want to go there with an empty drone. Because there's nothing you can do, right? If you're at a place that has no one waiting to get on board, what are you going to do?
Closest place.
You could do the closest place with a ninja. Yeah, there's certainly the ability you can get the location of where they are and you can calculate the distance. There's a utility in there that can help you to do that. If you want to do that, I would say that's more than you need to do for this assignment because you're not racing anyone. If you were racing someone, then you would want to go to the closest place first. But because we're sort of like just baselining it here, you don't need to race. You can just go somewhere that has... It's more like you just want to make sure you're making progress rather than making sure that you do it as fast as possible.
I thought we kind of were between us.
Okay, take it back. I guess if you want to be number 1, you do. If you want to go from A to A+, you do need to be the fastest. So I guess this also speaks to another strategy. Get something that works before you try and introduce artificial intelligence into the drone controller. Because you can really take way too big a bite on the first one. And a good thing to do is to just get the very minimal, easiest thing that you can possibly think of that requires no logic, and make sure you have that ready, make a copy of that, and store that. And then sort of say, okay, well, what's the next thing we could add to that? So, for example, what is the easiest thing that you could possibly do?
Go.
I mean, the one that we've got is pretty easy, right? There's kind of... The one where you just go to the first place on the list is pretty easy. What's one very, very simple thing that you could do to change that? Instead of going back and forth between Winter Hall and Trader Joe's or McDonald's and In-N-Out, what could you do?
Oh, go to somewhere there's a ninja.
Go to somewhere where there's a ninja. Great. So when so that would require a copy step. Right, where rather than just going to the first place, you're going to create your own set that has places that have ninjas, and then you go to the first place that has a ninja. That would be a great first place to start, because then you're like, okay, well, I'm not going random. I'm not going to the same 2 places over and over again. At least I'm going to a place that has a ninja. Right. Then once you have a ninja on board, then you need to say, well, now I got to deliver them. So step by step, you can increase. Okay, so. That's pretty good. All right, so then what would happen more broadly is, let's see, let me fix my audio. Still a little high. Someday I'll figure that out. Okay, so, and also, when you make the problem more complicated, if you were to introduce more drones under your control, you could leave the software working the same way, where each drone makes its own decision independently, but you could also have the drones work together in different ways if you wanted to introduce that. Also, when you start having drones that can carry more than one passenger at a time, then you could imagine different sorts of strategies where you decide, well, I'm at a given place and there's a person on board that wants to go to in and out, but I also have an empty spot on my drone and there's someone here that wants to go somewhere. So as long as there's someone here that wants to go somewhere, I should say, in addition to going to in and out, I want to go to this other place where where their person wants to go, because I want to make sure, maybe as a strategy, that my capacity is always maxed out. But again, a lot of that complexity is removed for this time because we can only hold one person. There's only one person waiting in line, and you're not at the same time racing against other people. I guess I should clarify that. The competition is not you guys working at the same time in the same world. It's you working in your own world and then comparing it to another drone controller working in its own world. Okay, so we've got about 20 minutes left, and what I would like to do is to work with you to try and write a very simple drone controller, or try to extend it a little bit so that I can help you debug the issues that you have when you try and just get really basic things working, so you can kind of get an understanding for the flow of the code. And then I'll bring up Slack so that if James is online or something, we can talk that way. All right, so for the remainder of class, we're just going to work on this assignment. I'm going to help debug. For the purposes of YouTube, I think what we're going to do is we're just going to end the YouTube broadcast. It's been a difficult day all around for YouTube. Sorry, remote participants. And then if you want to communicate about your particular controller and your remote and you're online right now, you can come up on Slack. Otherwise, what did we do today? We introduced the drone controller assignment. We took a little time to work on it. We synchronized the project. Boaz, your question?
If you're going to do that, then James can't work with us.
Is he not on Slack?
He is on Slack. But if he wants to, I'm assuming, watch are we working through, I'm confused what you mean.
I'm not going to work on my code. I'm going to let you guys work on your own code, and I'm going to help you debug when you run into logical errors. I mean, because it takes a little bit of working with it to understand what it is that you can do.
Yeah.
And so if James is doing that, or anyone else is doing that and is on Slack and has questions, we'll keep Slack up, but we'll shut down the broadcast. Okay, great. Thank you, people online, for your attention. Thanks for your patience as we dealt with the ghosts and the speakers today. And we will be back tomorrow, and we will be talking about tree structures. Tree structures are not something that we need for the drone assignment. Tree structures are a different kind of data structure, like linked lists or sets, that have their own kind of power. They're used in some of the data structures, in the implementations of some of the data structures that we use, but we haven't looked at that. Tree structures are a little bit like linked lists, but they have their own properties. So, okay. See remote participants tomorrow.